So this is the latest version of it. We're working on some, this is some work in progress that we're doing on some new meshes for the environment. You can see we have some light flicker stuff happening, which is just some math and the lighting. Um, this is using let me fly around here a little bit. This is using some of the new, some of the improvements that we've done to lighting here and stuff like that. See all the shadows and stuff. Lost. There we go. We have some different elements that we've added in here. So there's a little bit of physics happening now. So we're taking advantage of the physics engine that we put in here to give you a little bit of environmental physics with stuff. The environment we're building a lot of parts for the environment in order to have lots of different looks of rooms and spaces of different shapes and sizes. The editor, which is still pretty rough, but at the moment, there's some more to talk about that in a second. If you look, one of the things that we did was we had this concept of wanting to add more complexity to the environment without having to place a million little things. So what we did is we add this concept of layers into meshes. So this mesh has a bunch of different layers in it that have different elements. So here's a detail layer that I can turn on there. There's a cap here for this door if I don't need to use that doorway. There is this facade here that can turn on and off in different levels if you want more rock exposed versus more metal parts exposed. That's a shadow update taking a second. So the idea is that you can, that door frame, I can turn on and off if I don't happen to want the door frame in there. The idea is that we're building out a system where we have different room pieces that you build, and with those room pieces that you lay out, and then you can turn on elements on and off in those room pieces to get a different look without having to manually place a bunch of little meshes one at a time to kind of build something. It also lets us kind of optimize a little bit performance-wise and drawing and culling to have it kind of grouped together. Not that that's a major thing, it's a minor thing, but it's something that, that gives us a little bit of an advantage. Lighting wise, so that's what's going on there. We're still this is still work in progress meshes. We're kind of just testing things at the moment. There's a lot of pieces that are not in here, and there's no texturing on these things. They're all kind of like test textures and stuff. That's why you're seeing that. So this room has a bunch more, some different mesh pieces enabled in it and stuff like that. This is still some of the old test hallway, that we haven't replaced those meshes just yet. And there's some more room pieces and stuff that we'll work on. We're still working on some new ship models and stuff while we're at it here, but we just haven't, we don't have anything to share just yet. I think maybe the next meeting we'll have some more stuff to share. A little bit of work on shadows, but haven't spent a ton of time on it. We were mostly focused on getting this mesh system in place, adding in some physics, and working on some of the lighting stuff. So last time we talked about lighting. So this you can see around all those light icons. There's tons of lights in the scene. I think what's our actual, let's some metrics on in here. So a little hard to see, but you can see in the corner I'm running at super high resolution at the moment. So because this is running at 4K basically on my desktop. So running at 4K at over 200 frames per second, a 4.2 millisecond frame is pretty good nowadays. So I mean that's how long Unreal Engine just for lighting, much less the rest of the scene. Not that the scene is very complex, but things are running. Frame rates are pretty good and things are working pretty well here. We still have this shadow system in here. It's updating a bunch of dynamic lights at the same time as it's rendering the lighting here. We have the dynamic shadows on dynamic elements in the scene. And you can see that it's only updating the lights that we need to here. There were some I think there were some optimizations here we did last time since the last meeting. But I don't remember exactly which ones those are. Mostly it's just making sure that we're packing those lights into the shadow map efficiently and making sure we're giving them good sizes, as you're flying around. So the bigger thing here is we've moved on to, like, the first iteration of this, every pixel on the screen processed every light. So in this scene we have, like, there's 4 visible lights here, but there's over 33 lights in this scene all the way around in different locations. And before, it was taking all 33 lights, and every pixel it was saying, well, what's the lighting calculation for us, based on, these 33 lights, which ones affect, it wasn't even checking which ones affect these. Calculate the lighting for each one of these lights for every pixel and render the result. Not very efficient. So what we've done is we implemented the full clustered lighting. So I'll turn on the clusters now so you can see them. So these rectangles you see here on the screen are the light clusters. Each rectangle, it's really this is just the front plane of things. It's actually a volume in 3D, so it goes back into the far plane. It's currently, because of that, it's 3,000 light clusters essentially between the screen and the depth. For each one, for every cluster, it calculates what lights affect that region of space, right? So and what we're representing here is black would be, like, if I can get outside, bust through this wall real quick. The black areas represent no lights. The light green to darker green represent a few lights. And then when you start seeing yellows and oranges and reds and white, if it gets that far, it's representing like 16 lights in that cluster. And what this visualization is showing you is just the lights that are in the most expensive cluster in that, in the volume, right? Because each cluster here has depth. I forget how many there are. It's like 32 or 24 clusters down the screen. So it's just showing you the most expensive one. So you can say, like, oh, well, that one's a more expensive one, because it has a bunch of lights that are overlapping in that cluster, versus ones that don't have a lot of overlapping lights. So this is important in order to make sure that every pixel on the screen is not processing every single light in the scene. It's just processing the lights that are affecting that pixel in that area. And there's some other optimizations to do here. There's some clever ideas like, breaking it up so that you have lists based on normals so that you only affect pixels that are facing a certain direction and things like that. But I don't think we need to go that far. I think that what we have here is working pretty good. What would help us more really is occlusion, which is something that we need to, what we want to look into here soon after we get some more mesh work done here, is get occlusion working, where we can decide that, well, these meshes are not visible, so there's no need to calculate any lighting clusters or render anything in the distance. We're also not doing any sort of depth culling or anything at the moment, or a pre-pass kind of thing, so that it's still, we are sorting, so we are rendering closest to furthest, so we do get some benefit from that, where those far meshes are not even rendering at the moment, because, I mean, they're rendering, but the pixels are all being rejected because of the Z depth. But we could be doing better than that even. So yeah, we have some pretty good progress on this. We're looking to do some more. Currently I don't have this shooting affecting these guys, but that's the next thing. And then we have some more props we want to build. And I believe in the next meeting, we should be showing some closer to final art here, because there's still a lot of art that's missing that we want to get in here. A good mixture of rock and metal and, tech stuff, things like that. More props for placements and decoration. So it'll turn out pretty good at that point. And then we should also have some preliminary or maybe close to final models for the characters and, the enemies in the level. I guess it's not in here, but I can show it maybe. Dom was working on adding in some AI into here, so we have some bots in here now. So these guys are bots. They're not the smartest at the moment, but they're getting there. Do you want to talk about that a little bit, Dom? Oh, can't see you. There you are.
Can you hear me now?
Yep.
Yeah, they just have some very simple behaviors at the moment. For example, when you just load that level, it's just going through a patrolling behavior. When you go within a particular distance, then they go through a spotted sequence for a short period, and then they start attacking you. They obviously fire back, and you can kill them. And we fixed a bug yesterday where they just don't just respawn and keep attacking you.
Yeah.
But yeah, so
Zombies.
it's got some basic AI type behavior. It'll try and dodge stuff when you're shooting at it. So they're not just sitting there taking fire. And what's left to implement, for example, is a fleeing behavior where once it drops below a certain health, it'll go looking for friends nearby so that it can lead you into an ambush. That sort of situation. But we'll probably need to add a bit more like of an A star or knowledge. The enemies will have to know where their
Right.
friends are for them to do that. But maybe that's more than we need. But that's the plan with the AI at the moment. And if anybody wants to help with the AI, then obviously the code's all
Sure.
out there.
Yeah, sure. Yeah, I mean, to be able to actually flee and move around like that, we need some sort of pathing through the level. So we'd have to discuss that. And I have some ideas how we could do that potentially, this is again where you can lean into your game design. Like, since we're building this, not this level, but the other level builder levels, we'll probably drop these levels once we this old content, once we get the other content pulled together, and we'll just build 3 different levels from the parts that we have, just up to the latest standards and everything. But once we do that, like, because how the system works is kind of like a built out set of rooms, we potentially could build into every room pathing information, right? Like, every room has doorways, every room connects to another room or a hall or something. Well, technically, that's a path. So it could totally navigate that space as long as we describe it in that way. It could navigate the space just fine. This is actually how the original Descent worked as well. Like, its navigation was built into its environment because of how it built things. So that was, that was them leaning into their core tech into like, well, how do we do this? That's what they did, is they like, well, because we can render it, and we have this space, we can navigate that space. And that's how it worked. It's really, the original Descent stuff is pretty interesting how they did it. And it's weird, but that the environment itself was kind of an A-star system. It was a grid system anyway, so it was able to navigate that stuff completely. Looks like I must have broken something on these guys because they're just drifting and chilling until they finally see me. Do they have a distance visibility?
The distance visibility parameter.
Yeah,
So
like do
yeah,
they don't see me until I get a certain distance from them.
exactly. Yeah. Hmm.
Okay.
Well, yeah. And then if you get far enough away, then they'll just switch back to patrolling. They do pursue for a little while, but if you fly away, they should stop.
Oh yeah. I guess it just switched because it did something and then it clipped through the world.
Yeah.
So need to look into that. One thing you may have noticed is like this weird effect here. Like, what's happening there? That thing. So what's happening there is you can see that that's white in that area, which means there's tons of lights, and there are tons of lights in this demo. We did a lot of lights in this demo, and a lot of big lights. They cover like this full area. So because there are a lot of big lights, which you're not representing at the moment, you end up getting a lot of light overlap. So this center areas, we have cases where it's white. It's basically 16 lights or more. And how we have the current thing set up is it only supports 16 lights per cluster. That is kind of an arbitrary number that we picked. I know that that's not required. We can do a lot more lights per cluster if we want. By the way, this is also a debug build. If I ran it in release, it'd be running at a higher frame rate than this. But the frame time is mostly tied to fill rate. But yeah, it's because of that. I think that we're going to switch to storing the cluster data. I'd like to support an unlimited amount of lights per, and like if the performance is bad, that's something for you to deal with. Um, I know that Doom 2016 used lists of lights, and they kind of structured their data so they could have an arbitrary amount of lights per cluster. But I think they did put a hard cap at like 64 or something like that lights in a cluster. And we could do some more adjustment stuff like that. This is just kind of overkill, but we could probably make some more adjustments and we could support more lights here. There's no reason that we couldn't. We have plenty of overhead fill rate wise and stuff. You can see the frame time on this one is a bit lower, and that's mostly because of it's updating a lot of shadow maps. The optimization that I talked about last time about rendering dynamic and static elements of shadows separately, then combining them later is not in place. So I did some initial work there, but there were some bugs, so I put it on hold. I need to go back and work on that. That would reduce the amount of shadow updates that are happening here. There's also simple things that we're not doing. Like it currently, if it decides to update a shadow, it updates all 6 faces of the shadow map. It doesn't just say, well, what face do I need to update? Do I need to update all of them, or do I need to update, is the player in the center of all the maps, or is it just on one, or the dynamic elements, or are they just on one side? If they are, I just need to update one face. So there's a lot of optimization that can be done here. I don't know how much will get done when we decide that the demo is done, but we'll do as much as we can in that time. And just to give a good starting point to suit the needs of the demo and to make it look good and impressive and be something that inspires people to build their own stuff from it. And I guess that's it. Was there anything else from today? I don't think so.
Yeah, I mean,
I do. It's always
impresses me how good
it always impresses me how good the old content here is. That still looks fairly decent for how old it is. They definitely built it higher resolution than they absolutely needed. Back in the day when they did this, because I think the original demo, like all the videos, are like 640 by 480. It's like super low resolution, because that's what games were back then.
Yeah, it's fair to say the contributors, if you're in the lab and you're in the demo, you can help to also shape the demo for anything that you think we're missing or within reason. I don't think I'm going to go for any online multiplayer right yet, but
that's that's something we've discussed, right? Like there is a 2-player mode in here. I don't think I've fired it up. It's probably completely broken. We'll probably re-enable that because it's cool to show like how split screen would work, right?
Definitely broken right now. I've tested it.
It is, yeah. I figured it was. At some point we'll go in there and clean it up. There's no fundamental reason why it couldn't. It does require more, performance horsepower to do split screen, and you kind of have to structure things right. Like ideally you share your shadow map since you're all in the same environment. So you don't have. But you then have that problem, like if player 1 is close to the shadow and player 2 is far away from the shadow, what resolution should the shadow be? So there's some complications there to work out to make it work. Some games like Doom, I believe Doom 2016 doesn't have a split screen mode, so they just punt on that. It's like, we're not going to deal with that. That's too complicated. But we can take a pass at it and see if we can get a good balance of things to re-enable that. But really the important part about it was really just the core gameplay, the environment, the shadows, the lighting, the enemies. Those are the core things that we're focused on. But yeah, multiplayer is probably beyond this demo just because it's kind of a sidestep. There's nothing that prevents anybody from adding multiplayer for this. With the core physics engine that's in it, and everything's pretty much static except for some AIs and stuff, it'd be pretty easy to synchronize and to get to work in a network scenario.
Yeah, it's all good stuff. I'm going to try and keep the timers, just start to try and close things out now. Somebody will switch back, Tom.
Sure. And yeah, for sure, anybody that joins in on the fun here at this level. Oh, I saw my collision data on. That's the collision data. The collision is also tied to the different layers in these meshes. So when you turn on the layer on and off, you can turn the collision on and off as well. So see our collision stuff there. But yeah, anybody that joins in, we're always looking for suggestions and ideas. And if people were to contribute to the demo as well, that's totally a possibility. Just sync up with us first in the Discord, and we'll talk about it.